This is sand, a simple mixture of silicon and oxygen. And sand, or silicon, is what's used to make solar cells. And recently, Blue Origin just announced that they've made solar cells from sand from the moon. Let's break it down. Resource utilization on other planets and other planetary bodies is key to enabling scalable, sustainable human spaceflight architecture. And that's exactly what Blue Origin's done by their project called Blue Alchemist, where they've used simulated lunar regoliths, or simply just lunar soil that's been mineralogically and chemically equivalent to what's found on the moon. And they've used that to make solar cells and transmission wire. That's pretty cool. They've even gone so far as to account for the variability in the grain sizes that's on the lunar surface. Using what's called molten regolith electrolysis, Blue Origin has been able to extract silicon to a purity of 99.999%, which is often the amount of purity that you require for space-grade solar cells, often on the order of higher than the 3/9 that I specified after this decimal point. So there are 3 steps involved in the molten electrolysis process. You have to melt the material, you have to move the melted material to another area where you then perform electrolysis process to be able to extract different individual materials from the lunar soil. In this process, Blue Origin has melted the regolith to extract iron, and then silicon, and finally aluminum. And by the way, as a bonus, the byproduct of all of these reactants is oxygen, which is great to enable production of propulsion specific oxygen, as well as oxygen to support life support systems. Oftentimes, Earth-based manufacturing utilizes toxic chemicals for silicon production that has terrible effects on the environment, but Blue Origin claims that their space-grade lunar silicon extraction process does not rely on any toxic chemicals and simply relies on the lunar soil and sunlight. Well, solar cells can't be by themselves in the lunar environment because without adequate protection, they degrade in the radiation environment that's on the moon. So Blue Origin also had to perfect a way to make cover glass to encapsulate the solar cells on top of each other. That way, they're protected from the harsh radiation environment that's on the moon. Now look, this is all still a test bed, and there's a lot to uncouple and decouple and deconstruct before we realize whether this technology is scalable or not. I'm cautiously optimistic that it could be, but let's see where Blue Origin gets with the next few years on the development and scalability of making space-grade solar cells with dust from the moon.